Homework 7, question 8, higher maths. Find the stationary points on the curve y equals 2x cubed minus 9x squared plus 12x and determine their nature. Okay, so stationary points question is a differentiation question, so I'm going to go ahead and differentiate this one. I'm going to follow through a process. First thing I'm going to do is differentiate it. Once I differentiate it, I'm going to set the gradient dy by dx equal to 0. I'm going to then factorise and solve and find the value or values of x. I'm then going to find the y values. From there I'll do a nature table and just complete a summary of what I've found. So let's go ahead and do that. First thing I'm going to do is I'm going to differentiate. So dy by dx is going to be equal to 6x squared minus 18x plus 12. So that's it differentiated. For stationary points, dy by dx, the gradient, is equal to 0. And I've got 0 here is equal to 6x squared minus 18x plus 12. Okay. Now to factorise that, I could factorise it as it is, but what I'm going to do is I'm going to take out a common factor of 6 to make it that bit easier for myself. Okay, and from there I'm going to put that into two brackets. So what I have is x would be the first terms. I've got 1 and 2 are the numbers that we multiply together to get 2. That's a positive sign, so that tells me that both are either positive or both are negative. With that being the negative sign, they both must be negative. So from there, what I can see is that x minus 1 equals 0, or x minus 2 equals 0. So my x value is 1, and my x value here is equal to 2. Okay, so next I'm going to calculate the y values. Okay, what I'm going to do is I'm going to substitute the x values into the equation where I see y is equal to. Okay, so y equals, so what I'm going to do is for when x is equal to 1, I'm going to substitute 1 in wherever I see x. Okay, and if I work that through, I should get an answer of 5 coming out of there. Okay, I'm then going to do the same with the other value that I have for x, which is x equals 2, and I'll substitute 2 in wherever I see the x. Okay, 2x cubed minus 9 times 2 squared plus 12 times 2. Okay, and working that through, I should get an answer of 4 coming out of there. Okay, so what I have is coordinates. So my stationary points are going to be 1, 5. So my stationary points are going to be 1, 5, and the other one is going to be 2, 4. But as yet I don't know the nature of them, don't know if it's a maximum, minimum or a point of inflection. So what I'll do is I'll use a nature table. So the nature table. Okay, so nature table, I'll start off going along and down. What I'll use is I'll use my x values along the top. Now I already used 1, so I've got 1 here, and I've got 2, the other stationary point, so 2 for x. So they're my x values. Making up the table, I want to know what the curve is like, what the gradient's like when it's approaching 1. So I need to use a value that's to the left of 1, which is 0. I need a value in between 1 and 2. So I could use a fraction like 3 upon 2 or 1.5. And I want to know what the gradient's like when it leaves that point there, and I could use a number like, I could use 3. I could use 3, 4, 5, whichever number that I find would be quite easy to work with. What I'm going to work out here is the gradient. So dy by dx is my gradient. I already know at the stationary points, these will be 0, so my gradient is 0 at 1 and at 2. And then what I'll do is I will work out dy by dx for each of these values using either this dy by dx formula, this one here, or this one here. They're all the same. So whichever one I find the easiest to substitute my numbers into, and I'm interested to find out whether it's a plus, a negative value for the gradient. So substituting 0 in, I should get a positive value. Substituting 3 over 2 or 1.5, I should get a negative value, and substituting 3 in, I should get a positive value. So what that should do for me, it should show me what the shape of the graph will be. So the shape will be positive, it will then be flat, 0, it will then be negative in between 1 and 2, it will be flat when it gets to 2, and it will be a positive gradient when it gets beyond 2. So this one here is turning at the top, at the maximum point it can get to, so that's a maximum. This one here is turning at the bottom, the minimum point it gets to, so that's going to be a minimum turning point. So in summary, what I can say is that the curve has a maximum turning point at, and the point, be careful, is 1 and 5, 1, 5. And the curve has a minimum turning point at, and it's going to be 2, 2, 4. Okay? And that's my answer for that one. So looking back at it from a marking point of view, what I would do is I would give 1 mark for differentiating correctly. There'll be 1 mark for setting the dy by dx, or the gradient, equal to 0 for stationary points. And the place that I would be looking for that is here. And I would like to see it in there as well. Okay, mark number 3 will be given for the x values, and mark number 4 will be for the y values. Mark number 5 for the creation of the nature table, with particular reference to having dy by dx in here. And the 6th mark will come for a correct summary of what I've found during this investigation. Okay.